Hello and welcome to this second day of the HMN Network Wheel Reinvention Jam, for which I will program a live coding audio environment. So yesterday we just set up a simple project with a simple window with an empty view inside it, and we added an audio input and an audio output. We programmed the ring buffer to be able to pass the audio buffers from the input thread to the output thread. And this way we could have a nice callback in which we get samples from the input buffers. We can process these samples and write them out to output buffers. So today I think I will try to get a list of all devices, of all audio devices on this machine, and to let the user choose which device they want to use for the input and the output, and let them tweak audio parameters such as the sample rate or the audio buffer size. Then I think maybe it's worth it to spend some time having some meters and test tones to provide a way to quickly test if we have proper input and output. And if there's time left at the end of the day, I think we'll be able to start on the hot reloading capability. So let's get started with trying to get a list of all audio devices on the machine. Well, that was a bit of a trial and error, but I think we got it working. So we can now choose the input and output devices. I have in my application structure here, I have several lists of devices. A global list that contain all devices, and an input and output list to allow to correctly populate the menu to choose the devices for input and output. So these functions here are for initializing a device list. So we ask Core Audio to fill a list of device IDs, and then we allocate names for the devices, and we ask the name of each device. Then we have a function to filter the list of devices based on whether we want input devices or output devices. And that's a bit ugly. That's just looping through all the devices and asking the properties of its audio buffer lists. And then we check each buffer, and as soon as we find a buffer that has non-zero channel counts for input or output, we exit the inner loop, and we add this device to our filtered list. So in my main function, where I initialize all my stuff, I initialize the global device list, and then I filter to build the input and output device lists. Then I get the default device index. That's just a helper function that allows us to map a default device to an index in our lists. So we're just asking the system for default input or output device and looping through our list and finding the device that matches. So now that we have these functions, we can query a device list, and we can add widgets to our GUI. So I added a pop-up menu for the input device and a pop-up menu for the output devices. And when when the user selects a device, it will call audio set device for the input or the output. And audio set device is first stopping the audio unit and uninitializing it. You have to do that every time you touch some properties of the audio unit, like the format or the device. And then we set the device of the unit. We reset the format of the unit, which is apparently necessary. And we also have to try to set the format of the device itself, namely the sample rate, because the format we chose for our audio unit could be different from the one of the device itself, and it would be no good to hear ugly noises. So, and then I initialize my unit and I restart the audio unit. The naming is quite confusing here, because you have to use audio output unit start even if it's an input unit. But well, what you gonna do? So we can test that. I'm not sure how it will go with the in the video, because the setup, I have to record my mic and the system output is a bit involved, but we can. Where is my DSP function? Here. So here I'll just output a sine wave, and I'll try to change the output. Okay, so yes, I recompile and it crashed. Okay, if I recompile and I restart, so now we hear the pure tone, and we see that I have my devices in the menu box here, and I can select, for example, the speakers of the laptop. And so here it's going through the laptop. You should hear that going through the microphone. So, and we can go back to my multi-output device. In order to try the input, we could go back with our little ring modulation thing. Okay, I know. Yes, you're hearing my voice ring modulated with a big delay due to the USB microphone. I can try now to change the microphone and to choose the integrated MacBook microphone and here. So here you hear me with a lot less delay because it's going through the integrated microphone, and it's also less loud. Okay, so it seems to be working properly. So now what we're gonna do next is provide the user with a way to change the other audio settings, like the sample rate and the buffer size and the channel count, and then we'll add some helper visualization to quickly verify that we have inputs and outputs working properly. So like a simple level meter and tone test. But first, I think it's time for a lunch break. Okay, now we have the ability to set the parameters for our audio system. So we have our application here, and we can set the sample rates, the channel count, and the buffer size. The channel count apparently gets automatically remapped between the channel count we request and the number of channels of the device. So it will be worth investigating how we can control this mapping. Now it seems like with one channel and a stereo output device, the single channel gets mapped to both left and right. So as per the buffer size, it doesn't change as much. It's just that our DSP callback will get called with larger buffers. I first try to change the parameters incrementally, and it proved a little bit difficult because there was some weird behavior where you have to uninitialize the audio unit, and you have to wait sometimes apparently before it is able to change its parameters. And if you don't wait enough, basically you won't get any audio once you restart the unit. So for now, what I do is that I shut down everything, and I wait half a second, and then I reinitialize all the system. So we start with a fresh new audio input and output each time we change the formats. So it will be interesting to investigate how we can ensure to wait enough time but no more than what's needed here. As for the complete shutdown and reinitialization of the system, I'm quite okay with that actually. It's much more simple than trying to change each parameters incrementally, so I think I will keep it that way. At that point, I think we could get into refactoring and cleaning up our audio layer, and separating what's specific to macOS and what's general for the application. On the other hand, since it's a 7-day jam, it's maybe more interesting to continue pushing in another direction, and even if we let the code a little in a bit of a state. So I think it will be okay for now to have some functions that are not entirely separated into the proper layers. And we will now, as I told earlier, do little peak meters just to see, to quickly check audio input and output. So let's go. Okay, so now we have our meters working, that we have working input, and the output is displaying the level of the sine wave. I just added two levels for the input and for the output here. And then inside our render callback, for the first two channels of input, and of output. Here I call audio update peak level, and this function, it will just look for the maximum sample of the current buffer, and if that sample is higher than the level of the meter, it will set the meter to that sample, and if not, the meter is slowly returning to 0. And I just noticed that I think that sample should be an absolute value. Not very important because we still retain the maximum sample, and our signals tend to be symmetric for now, so it won't make a big difference, but it's still cool to make it right. Okay, so now I think we're okay here, and we have this function app_GUI draw meter. I give it a rectangle where to draw the meter, the level, and I'm passing also the application style. And I'm just drawing two rectangles, one for the background and one for the foreground. And in app_GUI, I'm just calling this function for each of the meters. Well, let's recap what we did today. So I started by making a list of all the audio devices on the machine in order to let the user choose what device they want to use for the audio input and output. And I added the pop-up widgets to let them select their audio devices. Then I added some more widgets to let the user tweak the audio parameters, such as the sample rate and the buffer size and the channel count. So it proved a little bit complicated because I tried initially to do it in an incremental way. So I tried to change, for example, just the sample rate or just the buffer size from the audio configuration. But there are some questions that I have to answer before I can do that regarding the functioning of core audio. And in the meantime, I realized that it's not really worth it doing it that way, because we could just say that any change to the audio configuration will result in some switching of the device's configuration, and it will result in some click or silence. So we have to shut down the audio device. So why not shut down the entire audio system and start with a fresh state? So that's what I did, and it's much more simpler and much more robust. So next I implemented very basic level meters. So nothing really fancy. It's just peak level meters for the first two channels of audio input and audio output, just to provide a way to quickly check that we have some signal on the input and that we are outputting something, so that if the configuration of the machine is wrong, or if some audio is muted somewhere, we can track the problem more easily. So that's it. That's not really standard matter. I try to have a return time that's approximately the same as standard peak matters, but I did not try to make it really standard. So we could spend some time having a really accurate matter, but I think it will do for now. And we will continue with that setup. I think we can hope to work tomorrow on the code reloading system. So I think the audio part is pretty much done. It would be great to have some time to clean it up and separate things into the right layers, and separate the macOS X specific parts and the generic parts. But since it's for a 7-day jam and the time is limited, I think it's more important and more interesting to push on some other ideas. That's some work that will have to be done at some point, but for now I think we'll be okay with that audio system. So tomorrow code reloading, and that's the part that will get that application to somewhere more exciting. So until then, have fun programming, and see you tomorrow. Bye bye.